Hi everyone, today we're doing question 18 on LeetCode called 4-sum. So if you've done 3-sum, this is just adding one more number into the set, such that all four numbers equal a given target that we have. So the idea behind this is that we're still going to be using a two-pointer approach. If you haven't seen my video on 3-sum yet, take a look at that first before approaching this one because they'll be sharing a lot of similarities. But the idea is we're going to first sort them, get rid of the duplicates, and then find all unique sets. So let's sort them first. So sort minus b. Then we're going to iterate. We're going to say minus 3 this time because that's the last index that can hold 4 elements. And same thing with j. +1, j +1, j +2, j++. We make sure that the second iteration will end over here because we can only hold 3 elements at that point. Then instead of doing 2 more nested for loops, we can just do a two-pointer approach. So we can say let k equals we can say j +1 and l equals numbers.length minus 1. Then the same idea with 3-sum. Iterate over the 2 pointers. So while l, find this out. And if our sum is target, let's push it into a result array. So the push minus I minus j minus k and nums l. Then let's get the duplicates. So we can say while nums k is equal to nums k +1, we skip over it. And while nums l is nums l minus 1, we skip over those. Finally, the last thing to do is just move the pointers. Cool. So let's say if the sum is less than target, then we need larger numbers, so we move our lower pointer up. Otherwise, we need smaller numbers, so we move our higher pointer down. So everything looks the same, just like 3-sum, but we do need to keep track of any repeats for I and j, so let's write those in. So let's see, this ends this. So we'll write it into here. We can say while nums j equals nums j +1, we skip over any duplicates values. And the same thing for I. Nums I equals nums I +1, skip over any of those duplicates. Then at the end, we just return our result. Let's see if this works. Works just fine, and works just fine. Cool. Runtime of this. Once again, sorting will not matter because this is a O of n log n. And obviously, this function over here is going to be asymptotically greater than n log n by a long shot. So this iteration over here is a quadratic n squared. Then we know that two-pointer is always going to be O of n. So we know that this is O of n squared times O of n, which will just be O of n cubed. So we can then summarize, since 3-sum is asymptotically bound to n squared, and 4-sum is asymptotically bound to n cubed, k-sum questions will always be O of k minus 1, sorry, O of n to the k minus 1 power bound. Because we can just keep adding for loops here to count for any extra numbers. Sorry, any extra iterations. So with that, I'll put a link to the question as well as my GitHub down below. Once again, if you're confused with any parts of this question, the approach is exactly the same as threesome. So please take a look at that first if you're confused. And with that, I'll see you guys next time.